Good morning everyone. Open page number 42 of our book Group Theory, chapter 2, Elements of Group, page number 42. Page number 42. Yes. Name of chapter is Elements of Groups. Yes. Okay. I have already taught you theorem number 7 given on page 41. Yes, now we have to learn theorem number 8. Theorem number 8. Yes, what is the statement of theorem number 7? Statement of theorem number 7 is what? That we have already learned. A non-empty subset H of a group G is a subgroup of G if and only if. Yes, when we say that H is a subgroup of G, if and only if H have to satisfy two conditions. What is first condition? If we take two elements from H, yes, then product must lie in H. And second condition is if A belongs to H, this implies element of this A, yes, inverse of this element A also belongs to H. This is the theorem 7. Yes, now we have to learn theorem number 8. I am teaching you theorem number 8 on page number 42. Yes, what is statement of theorem number 8? A non-empty subset H of a group G is a subgroup of G if and only if. You know the meaning of if and only if. I have told you in class. Yes, if and only if A and B belongs to H, these two elements suppose belongs to H, then this implies AB inverse belongs to H. So what is meaning of if and only if? Meaning of if and only if is like this. Sign is like this. See, if and only if. If and only if means we have to take given first part as a given and we have to show second part, yes, in a proof, and after that take second part as a given and show first part as a proof. Yes, so let's see the proof. Take first part. What is given to us? Given as a non-empty. Yes, what we have to show? We have to show second part, and then conversely we have to take second part as given and we have to show first part. Yes, a non-empty subset H is a non-empty subset of a group G. Yes, and we have to show what? We have to show AB belongs to H implies AB inverse belongs to H. Yes, this is we have to show. Yeah, so simply they have given us H is a subgroup. They have given us H is a subgroup of G. H is a subgroup means what? Inverse belongs to H, identity belongs to H, inverse belongs to H, identity belongs to H, and closure property satisfied by H. Yes, of course, if we take two elements from H, so obviously inverse belongs to H, identity belongs to H, closureness property satisfied, so we can directly write AB inverse belongs to H because they have given, since they have given what? H is a subgroup. Understood? Yes, now we have to prove converse part. We have to prove converse part means take second part as given. Yes, what is second part? If AB belongs to H, this implies AB inverse belongs to H. Yes, so conversely let A and B, these two elements belongs to H, and we have to prove what? We have to prove H is a subgroup. We have to prove or to show what? H is a subgroup. Yes, H is a subgroup. So simply take a element from H. Suppose A is a element that belongs to H. So this implies what? A, and inverse of A also belongs to what? Belongs to H. A into A inverse is identity. Identity also belongs to H. Since we can write like this, since H is a subset of G. Yes, and identity belongs to H. Element A belongs to H. Implies what? Implies E and A also belongs to G. Yes, G is a group. If G is a group and A belongs to G and G is a group means what? G satisfy G has the inverse element, identity element, and closureness property satisfied by G. So if A belongs to G implies what? A inverse also belongs to G. Yes. Okay. So we can write by hypothesis. E A belongs to H. Yes. So this implies E into A inverse also belongs to H. That is what? That is A inverse belongs to H. If we take B element, B belongs to H. So we can write, if A belongs to H, then A inverse belongs to H. If we take B belongs to H, we can write B inverse belongs to H, obviously. Yes. So thus A belongs to H implies A inverse belongs to H. B belongs to H implies B inverse belongs to H. If we take two elements, yes, these are the four elements, A inverse, B inverse. If we take two elements A and suppose B inverse, both belongs to H. Yes, so this implies what? A, B inverse and inverse, because they have given us what? AB inverse belongs to S, means if we take two elements, then multiplication of first element into inverse of second element belongs to EH. So we can write like this. So this implies A, B inverse means B. AB product of A and B belongs to H. And by theorem 7, this is for all AB belongs to H. So we can write by theorem 7, we have already discussed theorem 7. Yes, by theorem 7, H is a subgroup of G. Yes, understood. Thank you.